Hello, my name is Jamil Siddiqui, and welcome to I'm Not Afraid of the Exam's Afraid of Me. Today we're going to be looking at the September 6th problem, which has to deal with limits. So let's get started. In this problem, you're given a graph of f of x, and you're asked two different limit problems. The first limit is x approaches -4 of the function, and the second limit is x approaches 1. Let's take a look at how to handle limits and what it really means to be a limit before we dive into these first two questions. If you're going to be working with me, one of the most important things you need to know is that I treat mathematics as a language. And actually, when I teach AP Calculus, we actually talk about 5 different languages that we're going to become fluent in as the year goes on. Let's take a look at those. First, of course, is just the language of English. We've got to be able to communicate with each other and be able to speak. The second, my favorite, the language of mathematics. This is the language of notation and symbols that is precise and that we can use. It's a beautiful language. As a matter of fact, you'll hear me refer to it all year long as the language of love. Up next is that hybrid language, where we start talking in English, but we use some math in between, and we interchange it freely because we're becoming fluent in the two. The next language is the graphical language, where we're using a picture. Every picture is worth 1,000 words, so we should be able to use it to tell our stories. And then the last language is when you're given a table of data. That data should be interpreted and used to our advantages. So now let's really focus on the idea of what a limit is. So when we say a limit, what exactly do we mean? What do we mean by this limit? In English, a limit is nothing more than a guess. All we're trying to do is guess the value of an output as the input gets closer and closer and closer to a certain number. Now, it's important that you know that the limit is not asking what the actual output is. That's a different question. We would denote that by saying f of the number and plugging in. This, we're guessing, and what that requires is us being a little sneaky about it. So, we've got to learn to read and understand our notation. Let's go take a look at how we write limits using the language of love. Here we have the limit of f of x as x approaches -4. Again, we're trying to say that this is a guess. So let's see how we would translate this. We are guessing, and that limit part means guess. That's every time you see limit, you're taking a guess. So we're guessing the output of our function. F of x is always the function output, so that's what we're looking for. As the input gets closer and closer to a certain value. You can see that each of these 3 parts is vital in saying what the limit means. Whenever you're doing a limit, do not leave out any of the 3 parts. On the AP exam, that would be considered poor notation. You would be subject to losing points if you leave out any of those 3 pieces when we're talking about a limit. Now let's talk about limit, how we're actually going to use it and earn points on the exam. So we're going to be looking at keywords all throughout the year. And the key word in this one is all about telling us whether or not the limit exists. We're going to know that that limit exists if the limit of f of x as x approaches a from the left is equal to the limit of f of x as x approaches a from the right. Now what that means is we're going to have to sneak up on the value coming from both sides of the graph, coming from the left and the right. If those two things are equal, and only if those two things are equal, we'll be able to say that an overall limit exists. In other words, the guess coming from the left must agree with the guess coming from the right. Anything else, that limit's going to be undefined. So we've got to check from both sides and make sure they're equal. If we look at this and we think of it kind of graphically, we're going to say the limit will exist if the limit from the left is equal to the limit from the right. And what that means is when we come from the left side and we come from the right side, those two places will agree. We'll find the value there, that will be our guess, and that will say that the limit exists. If you want to earn points on the AP exam, this is what you have to know. Every single time you're asked to justify a limit, you've got to use the following statement. You've always got to say and show that the limit coming from the left equals the limit coming from the right, and then that will equal the overall limit. Remember using the correct notation. You need all 3 parts. So every single time you're asked to justify a limit, this is what you need to write with the example that you're given. Let's get back to our question and see how we would handle this. When we're doing this first one, what we want to know is we want to find out what the limit is as we're approaching -4. So that means coming from the left side of -4 and coming from the right. You're going to notice that every time I do a graphical limit, I'm going to have these 2 little rectangles ready. Now, in my class, we refer to these as the cloud. And what we want to do is we want to put that cloud directly over the values so that we're not getting caught up on what the actual value of 4 at -4 is. We can't even see that value. What we want to do is we want to find out what the value is as we approach. So as we come in this direction like this, we're asking, what's our guess going to be? What's the y value that we would guess? Now you can see we're getting a consistent y value of 2, 2, 2, 2 everywhere along this line. So if we were to actually guess where we are underneath this cloud, we would guess the y value of 2. The way we're going to denote that is we're going to take the limit as x approaches -4 from the left-hand side. And that is going to be this value right here. That's going to be our value of 2. Okay. So now what we're going to do is we've got to do the exact same thing, but this time coming from the right-hand side. So we're going to approach that cloud again. And again, we're not going to know exactly what's underneath the cloud, but for the limit, it doesn't matter. So as we approach coming from the right-hand side, we're coming through the values from -1 to -2 to -3, and we're approaching -4. What we're seeing is we're consistently getting a y value of 4. So if we were to guess what's under this point right here, our logical guess would be 4. So what we're going to do is we're going to do the exact same idea, only this time we're taking the limit as we come from the right. So we have to change that notation. We have to make it 4 from the right-hand side. And the guess that we're going to make this time is 4. Now, to find the overall limit, what we've got to do, check to see if the left and the right agree. As we look at these two, they do not agree. Okay, they don't agree at all. The only way the overall limit can exist is if your left and your right agree. If this is the case where they don't agree, the answer will automatically be undefined. Let's take a look at the second example now. In this particular question, we're doing the overall limit as x approaches 1 of our function f of x. So remember, whenever we take an overall limit graphically, we've got to check coming from the left and coming from the right. So I'm going to start by taking the limit as x approaches 1 from the left of this function. Remember what that means. That means I'm going to be coming from the left-hand side and traveling towards our cloud. Again, I always want that cloud there because the actual value has nothing to do with predicting the limit. So knowing the actual value can actually be detrimental. Putting the cloud there makes sure we never make that mistake. So as we're coming down this way, we're going to guess that our value would logically be the output 1. Now what we've got to do is we've got to come from the right in this situation. So as we come from the right, we're going to be going down in this direction right here. And walking this way, when we get to that cloud, we're going to predict where we're going to be. And that's going to be right here. Again, that's going to be the value of 1. So we say the limit as x approaches 1 from the right of f of x is also equal to 1. Once we've got these two limits, we know that they agree. And anytime they agree, the overall limit will be the same value. So we've got 1 there. If you're asked to justify this on the AP exam, what you would say is that my overall limit equals 1 because my limit from the left A is equal to my limit from the right. Again, make sure you use the correct mathematical notation. I may be saying the limit from the left, but when I'm writing it, I'm using all 3 parts of that limit every single time. If you have the answers up here, you're showing you know they're both 1. You don't need to put them down here. If you're going to be complete, you might want to just remind your reader on the AP exam that this is because 1 was equal to 1. Today we took a look at graphical limits. Graphical limits are always done in the 3 parts. You've got to take the limit of f of x as x approaches a from the left. You've got to take the limit of f of x as x approaches a from the right. You've got to see if they're equal. If they are, your overall limit will exist and be the same value. If they're not equal, you can automatically write down that the limit is undefined. Come back next time where we're going to take a look at how we work with algebraic limits and how we deal with those. Remember, I'm not afraid of the exam is afraid of me. Hope to see you next time, and if you like these videos, please make sure you subscribe and click the thumbs up button below.